Good morning everyone. So for today's class physics, we're gonna enter a new chapter, chapter 8 from your textbook, which is called temperature. Okay, so in this topic we will learn about the principle of thermometry and also the practical thermometers. Okay, the next one, principles of thermometry. So at the end of this topic you will know how to explain these two objectives. Okay, so the first one is explain how a physical property which varies with temperature may be used for the measurement of temperature, and you also have to state the example of such properties. Okay, explain the need for the fixed point and state what it means by the ice point and steam point. Okay, let us begin. Okay, so the first one will be the first subtopic 8.1, what is temperature? So they say that the temperature of an object is a measure of the average kinetic energy of its particle. Okay, you have a diagram here where you have two conditions here, the higher temperature and lower temperature. So if a hot object is placed in contact with a cold one, in contact, which means they are touching together. So there is a transfer of thermal energy from one to the other. So basically you can see that this energy moves to here. So from the hotter regions go to the colder regions. From higher go to the lower temperature. So when both objects reach the same temperature, the transfer of energy will stop, because the average for a particle is the same in both, which basically means they are now in equilibrium. Balance. They are now balanced. If you say here 50 degrees Celsius, here also after like few minutes, this region also will become 50 degrees Celsius. They both will have the same temperature. When they both have the same temperature, so this energy will stop transfer. So temperature, so they say that the definition for temperature is, so this is the definition of temperature. So it say temperature is a measure of how hot or cold a substance is. So you have the thermometer. What is thermometer? So thermometer is an instrument used for measuring temperature. Normally we use a thermometer nowadays, and it's based on the thermometric properties of matter. Basically you will have a three scales are used for measuring the temperature. Let's see what it means by three scale. The temperature scale, so the first one you have a Fahrenheit, second one Celsius, third one we have a Kelvin. This number shows the Fahrenheit for Fahrenheit, and this one for Celsius, this one for Kelvin. So let's say normally people will prefer using this unit, Celsius. Nowadays, in modern nowadays. So let's say you have a 0 degree Celsius. When you have a 0 degree Celsius, which means that your Fahrenheit will be equal to 32 Fahrenheit. How about for Kelvin? So when you have a 0 degree Celsius, so your Kelvin will be equal to 273. How about when you have a 100 degree Celsius? So which means you will have a 212 for Fahrenheit. For Kelvin you will have a 373 Kelvin. So these are the unit. Kelvin you have a capital K. Fahrenheit you have this F. C stands for the Celsius. So temperature and heat. Are temperature and heat are the same? So the answer here is say no. Because a spoonful of boiling water, 100 degrees Celsius, will have the less thermal heat energy compared to a beaker of boiling water at the same temperature. So this is the spoonful. Let's say you have a spoon filled with water with a temperature of 100 degrees Celsius compared to this one. Let's say the amount of water here, if you compare with this spoon, is much higher compared to this one, right? The amount of water inside this beaker, but the temperature is is the same, 100 degrees Celsius. So what you can say that the thermal or heat energy is basically so refers to the amount of thermal energy that is okay, being transferred from a hotter to a colder region. Okay, heat energy is basically relies on the amount of the substance has. Okay, so the next one here will be the principle of thermometry. Okay, so a thermometer, okay, as you know, is any instrument which is used to measure the temperature. Okay, the thermometer needs a scale to be used effectively. Okay, there are several types of thermometers. Okay, the choice of which to use is depend on the range of the temperatures to be measured, the accuracy required, and also the physical condition in which the thermometer will be used. For example, like this one. Okay, physical properties: when you have a volume of a fixed mass of liquid, so you will use a thermometer, liquid in glass thermometer. Okay, so when you have an electrical resistance of a metal wire, so you have to use the resistance thermometer to measure the temperature here. Okay, how about the electromotive force, which is the EMF? So you will use the thermocouple. Okay, so the last one, okay, in case you have a pressure of a fixed mass of gas at constant volume, so you have to use the constant volume gas thermometer. Okay, so this is show you you have a different types of thermometer. Okay, and they relies on different physical properties. Okay. Okay, let's say you have to here you have to construct or you say okay constructing a temperature scale. Okay, constructing a temperature scale. So you have three steps here. Okay, step one, you have to choose a physical property which changes continuously with temperature. So this is the physical properties. Okay, in the step two, you will have to choose two fixed points, the upper and the lower fixed point. Okay, and then the last step, okay, which is talking about the divide the temperature between the two fixed points into many equal divisions. Okay, so here you have a common temperature scales. Okay, so temperature in everyday situations are usually measured in degrees Celsius. Okay, and also referred to sometimes as the centigrade scale. Okay, so this basically is the second subtopic at point 2. Okay, so you have two fixed points. Just now, as I mentioned earlier, you have the upper one and the lower one. Upper one will be here. Okay, lower one will be here. Lower point, upper point. So normally they will say that lower point will be the 0 degrees Celsius, which means the freezing point. Okay, freezing point also means the ice point, okay, of the pure water. Okay, how about the upper point? Upper point normally you will put a 100 degrees Celsius, the boiling point of pure water. Okay, these are the two fixed points. So these are basically is the some of the temperature of object in this world. Okay, the sun surface, which is equal to 6,000 degrees Celsius. Okay, you have the Bunsen flame, you have 1,500 degrees Celsius. The human body normally normal body temperature is 37. Okay, freezer food, you have negative 20 degrees Celsius. Okay, and the last one will be the absolute temperature. Okay, absolute zero temperature, which is equal to negative 273 degrees Celsius. Okay, so the centigrade scale. Okay, so how exactly is the thermometer calibrated? Okay, so as you know that if the scale is divided up into equal divisions, okay, then it is known as a linear scale. Okay, upper fixed point will be 400 degrees Celsius and lower fixed point will be 0 degrees Celsius. Okay, so let's see one by one here. Okay, you have an ice bath here. Okay, which is you have the cold temperature here. So 0 degrees Celsius is defined as the melting point of a pure ice. Okay, so any impurities will affect the value obtained. Okay, 400 degrees Celsius is defined as the boiling point of pure ice. Boiling point, boiling must be at the standard atmospheric temperature, which is equal to 1 atm. Okay, so having a fixed the 0 degrees Celsius and 100 degrees Celsius, the rest of the scale is made by dividing the length into 100 equal divisions or degree. Okay, so if we're dividing them into 100 equal divisions, so you have the gap, or you can say the interval between from point 1 to point 2 will be 1 degree Celsius. Okay, That is what it means by 100 equal divisions of degree. Okay, let's say us to construct a liquid in glass thermometer. Okay, the step 1 will be the selection of the tube. Okay, the smaller the bore, which is this one, okay, the capillary tube, okay, the greater will be the sensitiveness of the thermometer. Okay, so making the glass bulb, so you have a glass blank here, okay, filled with the bore inserted, you insert the bore in the middle. Okay, and then you have to heat, okay, you heat this thing, okay, you heat this glass with the bore, okay, until it become like this, okay, forming a reservoir. Okay, this will increase the sensitiveness of the thermometer. Okay, so at the end you will fill with fluid. Okay, insert a fluid, put fluid inside it. Okay, and when you do this, okay, you conduct it in vacuum chamber. Vacuum chamber, which means this area is totally a vacuum, no pressure exists here. Okay, so when you insert the fluid into the, let's say, the thermometer, okay, making the glass tube, making the glass bulb. Okay, after you finish with step 1, so the step 2 will be the determination of the fixed point. Okay, though the thermometric scale that correspond to the melting of the pure ice in distilled water and the boiling point of water at standard atmospheric pressure. Okay, so your melting point and your boiling point. So basically they will put at 0 degrees Celsius for melting point. Boiling will be 100 degrees Celsius. Okay, so this is your ice point. Okay, ice point is the temperature of the pure melting ice at standard atmospheric pressure. Okay, and it assign a value of 0 degrees Celsius. Okay, this is how you can do the experiment. So you have the Victor stand here. Okay, this is your melting ice. Okay, a funnel. Okay, you put the ice point here. Okay, ice point. So when inside this normally inside the thermometer, okay, you will fill the liquid. The liquid is known as a mercury. Okay, and sometimes you also can use alcohol. Okay, but normally we will use a mercury. Okay, so when you put inside here, you put the thermometer inside the melting ice. Okay, you will see that this mercury is inside here. Okay, it will, let's say, it will increase and then it will stop at a certain point. So that will be your 0 point of let's say ice point for your thermometer. Okay, this is for your ice point. That's step 1. Okay, and then you have to look into the steam point. Okay, this is the experiment steam point. Okay, steam point is the temperature at which the boiling water changes into steam at standard atmospheric pressure. Okay, and it is assigned a value of 100 degrees Celsius. Okay, so when you want to find the steam point again, okay, you insert the thermometer, okay, above the boiling water here. Don't put inside here, okay, the thermometer. Put above the boiling water. So this your mercury. Okay, you know that as I mentioned earlier, okay, your mercury inside the thermometer will increase. Okay, it will keep increase until it stop at a certain point. So let's say it stop here. So this will be your steam point. Okay, so now you have your steam point and also your ice point. Okay, at the end of the step, on the Celsius scale, so the interval between the ice point and the steam point is divided into 100 equal divisions for easy reading. Okay, each division is equal to 1 degree Celsius. Okay, so let's say you have if the two fixed points are marked, okay, intermediate temperatures can be calculated. Okay, so let's say you have this, okay, you have ice point, okay, you already know your ice point, and also you will know the steam point. Okay, but let's say you don't know how let's say you don't know how to divide between these two. Okay, and you have but you want to find this point. What is the temperature here? Okay, what is the temperature here? So basically, even though you don't know what is your reading here, okay, you don't have any reading here, but still we can use this method to find the temperature here. Okay, so let's say you don't know, if you don't do the, let's say you don't do the freezing point and the steam point, okay, but you want to use the thermometer immediately. Okay, so you can still find the temperature of the object. Okay, let's see what I'm trying to say. Okay, so if the length of the mercury thread, okay, at the ice point 0, okay, ice point is 0 degrees Celsius, at steam point 100 degrees Celsius, and when they immerse in a liquid of unknown temperature, okay, this is your object, okay, unknown temperature of your object, which is the liquid. Okay, so you have this one. Okay, the symbol you put like this one. Okay, this one stands for the length. Okay, length. Yes, this is length. Okay, L shape length. So you have this one minus this one. Okay, this one minus this one. Okay, at the end you will get the temperature of the liquid that you measure. Okay, so let's see this one. So this is the object that you want to measure. Okay, the temperature, this is the length, minus with the ice point. Ice point, this one. Okay, the length for the ice point. Okay, and then you divide. Okay, you divide. This is the length for the boiling point, minus with the ice point here. Okay, you have to know this. Okay, this one stands for length. Okay. Okay, so this one minus this one minus this one, you have to times with 100 degrees Celsius. At the end, you will get the answer in temperature. Okay, degrees Celsius. Okay, and also the equation can be modified when the thermometers uses other physical properties. Okay, now you use a resistance. Okay, now you use the length. So how about if the questions give you resistance? Okay, so the question can be written as, okay, this is the degree, this is the temperature, equal to resistance at the resistance that you want to measure. Okay, minus with the ice point resistance, divide by, this is 110 means for the boiling point. Okay, boiling point resistance minus with the ice point of the resistance. Okay, again you have to times with 100 degrees Celsius. Okay, RO here is the resistance of the platinum wire at ice point. Okay, R100 is the resistance of platinum wire at steam point, and R delta, we call this a delta, is the resistance of platinum wire at the unknown temperature. Okay, normally this is the unknown. Okay, unknown temperature. This is in length, this is in resistance. Okay, so for today's class, I want you guys to do the example here. So you have total 5 questions. Okay. Okay, so that's the end for today's class. So thank you for listening and watching this video.